Good morning, everyone. Welcome to One Concept, Multiple Tools, Multiple Learnings video series. And this is my sixth video. And today we'll be discussing about the graphs. I think it's sixth or seventh video. I think seventh video. And we'll be discussing about the graphs, especially what kind of graphs? Graphs that are useful in case of kinematics and mechanics, especially kinematics. That is your SC graph, VT graphs, and AT graphs. So what are the tools available? How do we utilize it perfectly? How do you gamify it? So this is what we'll be looking into it. Okay, so let me share my screen without wasting your time. Let me start working on this. Just give me a moment. Right. So the tool which I'll be using here is about the Java Labs. So here a girl is dropping a ball from here, and we need to find out how does the distance and the velocity increases or decreases. That's what we need to look into it. So what you do is you just come down here. You can say time, distance time, or you want distance velocity, velocity time. You can get over here. Now what I'll do is I'll just keep it back over here. And then that is the time I have changed. And then what I do is I need to run this. Just a moment. Just blocking my view. Okay. So you have a run button here. Click on the run button. So when you click on the run button, you'll be able to see that the distance time and the velocity time graphs are being shown over here. So you can ask the question like, for example, why are these dots which are seen over here are not being equispaced, but they are farther located along this line, which means the distances are not the same for every interval of time. What is it? And what is the relationship connecting these two? So you can ask something like this also. And next is, let me go to the next one. So this one gives you something like, if I have the graphs like distance time, velocity time, and acceleration time, I can ask this as a quiz. Okay, and I say, okay, I ask one of the student to say, okay, so if the velocity is changing, let us say, for example, if the velocity becomes 0 over here, from this point, if I make it 0, then how will the graph change? How will the graph of x versus t change? How will the graph of acceleration versus t time change? Okay, so I keep it over here. Then I observe that the x here is increasing. There's a plateau region over here, and after that it's increasing like this over here. Okay, and similarly, what happens to the acceleration? Acceleration suddenly increases, decreases. All this you will be able to look into it. Okay, in a similar way, I can change the velocities downwards, leftwards, and so on. Now, if I want to find out how does the displacement time and velocity time change when the acceleration is changing, the next one here. Okay, so you go for this one here. So here these two are said to be a constant, that is you will not be able to vary them, but you can vary this one here. For example, if I say the acceleration is changing and I keep it to some level, say for example, I keep it to some level. Let me refresh it. Something wrong. Okay, so it's been going a bit slower. See, earlier it was here, now I pulled it down also here. So what will happen in that case? Okay, so I can get to know. See, now again it has changed over here. So I can pull this over here like this. See, I am able to pull. And as a result of it, how does the graph change? And you can ask the question, why does this happen? Okay, when acceleration reduces, why does the velocity time graph also reduce? Why is the displacement also reduce? You can get to know more about this. Okay, so all these questions you can ask. See to it that these are restricted only for a constant acceleration over here. That means you will be able to use the what we call the equations of motion. Okay, let me move on to the next one. This graph can be used as a quiz. So shown here something like the path of a particle, how does it move? Okay, and then the dots represent what is the distance traveled in a consecutive interval of time, and this is what has been shown. Now there are 11 graphs, something like a quiz over here. So these are 11 graphs over here. Currently 8th graph is being active. So there are 11 graphs. Type a letter to view a graph. So you need to view a graph which satisfies the answer type on the answer check answer button. So what to do is let me check the first graph. The first graph displays like this. Now the question is that is this graph and is this scenario both correct or not? Now here what's happening? Distance is increasing with respect to time in an exponential way. But here you see the distance, this is for consecutive time intervals. Distance is not increasing like this. So therefore A is incorrect. Let me go for B. When I go for B, what happens? So velocity seems to be a constant for certain interval of time, and suddenly, okay, it takes some time, it becomes 0, and then once again, okay, velocity starts increasing over here. Okay, is this the case? You see, velocity is constant here, takes some time to rotate or change the direction. Once again, velocity is constant. Distance between the plots, this one spots is it's constant. So this is also incorrect. I'll just do one of them. The rest of them you do it yourselves. Then see, now what's happening here? Velocity seem to be a constant. So this is also incorrect. Now let us go for D. Now what is D over here? Velocity, the position is seen to be decreasing. The displacement is seen to be decreasing. Is the displacement decreasing? No, displacement is not decreasing. It is seen to be increasing over here. So D is also wrong. E. Now what's happening? Position is seen to be constantly increasing. Of course, constantly increasing, and it goes to some point, and after that it keeps on constantly decreasing. The decreasing part is not seen here. So E is also incorrect. Let us go to F. Now here what's happening? Position, the velocity seem to be decreasing, increasing. Velocity seem to be increasing in the opposite direction. No, this is also incorrect. Because going the forward direction, velocity is constant. So F is also incorrect. Let me go for G. When I go for G here, the velocity is seen to be, the position is seen to be increasing. That means what? Displacement is becoming higher. Then it stops for a while. It stops for a while. And once again, the displacement keeps on reducing. Okay, displacement keeps on reducing. So this is what is being seen. So probably G could be your answer. Let us look the rest of them also. Okay, let me go for H. So velocity is decreasing with time. No. Now I. Position is decreasing with time in non-linear fashion. No, position is not always decreasing. It is increasing, then decreasing, right? So that's what you need to look into. Let me go for J. Now position is increasing, remains a constant, again increasing. No, because it's decreasing. Then position is decreasing. Which one did you look into for the earlier? It was G. I think G should be your right answer. So what I will do is I'll click on check answer over here. And G is the right answer, 9%, right? Because total 11 questions have been asked. So of course, 9%. If you get a green color, then definitely you answered it correctly. Okay, so like this, you will be able to use it. So it's a wonderful tool for someone who wants to give this as a quiz and ask your children to participate into it. And if they do not get an answer properly, you can ask them why don't they get it? What is the reason for it? You can ask, you can also do something like peer learning between them. So this will be a very useful one. Let me go on to the next one. Velocity time graph. So this particular graph, you need to drag it from here because I think it's a Java based tool. So you need to drag using this toolbar over here. This is very similar to what we had looked over here. Very similar to this one here. But the only difference between this tool, which is this tool, and the earlier tool is that here you can change the velocity, and that too for a larger distance. Okay, and thereby you would be able to see what's happening. There it was only for a smaller amount of time. Okay, so therefore this is also a good one. Either you can use this one or you can use the other one. Both are same. Then comes the speed time graph. Now here is a gamified version. So what is the gamified version? You have a scooter here. There's a speedometer being given, and there is also a VT graph given over here. Let me drag this. Right, there's a VT graph given over here, which is given in kilometer per hour. So this kilometer per hour will be mapped. Time will also be given. Now, if you look into this, for example, I can change this here. Okay, if I click here, say if I click anywhere over here, if I click here, maybe my mouse is not so sensitive. I can rotate the handle and the scooter starts speeding up eventually. That's what you can see. It's here. I'm sorry. It should be anti-clockwise. We do it like this, right? I'm sorry. Yeah. Okay. So now you see, I rotate it anti-clockwise. Okay. So therefore, the scooter starts speeding up, and you can see the corresponding value of the VT graph, right? So its VT graph is like this. So the speed is higher. It's accelerating. So it goes to around 90, 95 kilometer per hour. Then it is going at a constant speed, as you see. And later on, you can reduce it also here. See, velocity is reducing. If you want to change the indicators, for example, it's a straight road, there's nothing to turn over here. Okay, say for example, I can change the indicators here. I can put the indicators on here. You can put the indicators left over here. This is just a gamified version. One can use it. You can use also the horn also. You can use the horn here. You can click on this and you'll be able to get the horn, right? And you can put the brake also. For example, if I'm moving at a much faster pace over here and I want to apply a brake and I want to find out what happens to the VT graph. See, I applied a break, and you can observe that this line immediately came down here, right? So all this information you can ask your children to play. Of course, the lower grade children like MYP4 or maybe 8th, 9th grade students, if they have the VT graphs, okay, they will be able to appreciate this and enjoy this one over here. Move on to the next one over here. So next one shows random displacement and velocity simulation. So in all the above, whatever we have seen so far, we have seen that the velocity and acceleration can be changed on our way. But here it is completely random. Okay. So what I do is I click on the start over here, and you see this is how randomly the object starts moving. Okay. So you have no control over it. You can easily, it can change anyway. So as it changes over here, now look at the graphs. How does it change over here? You can change displacement time, or maybe you can also click on this. You can get a velocity time, and you will be able to see how does the velocity time changes. This is what literally happens in our traffic, right? So you don't have something like a predefined one saying that, okay, I'm going to start with 30 km per hour, always go at 40 km per hour. Then when I'm coming to a stop, I'm going to come at 50 km per hour. We're not doing this. Okay, we're going to go in a random way. So as a result of it, this is what you can see over here. Okay, so this is also a good one, a gamified approach to show to students, okay, how in real life, okay, what is the kind of graph we can expect. That's what we can do it here. Next, okay, let us look at this one. This is also a gamified version over here. So shown something like this, a cart over here, and then you have a cart here, and you have a sensor over here, and then you are going to push this. Okay, when you click on push, it goes and hits here. And the interest here is that how does the distance time graph, velocity time graph changes over here. Okay, this is a normal one, but what I found interesting is in this one. Now here you see there is an inclined plane. Okay, and you ask the student, okay, how does the velocity time graph will be denoted? You'll definitely say it is just a straight line. Okay, maybe it is a straight line which is going upwards over here. Let us show what happens over here. Let me click on push. Now what do you see here? The displacement time graph is shown over here, right? This is a displacement time graph, and if you look at this is your velocity time graph. Okay, it goes from 1.5, minus 3, minus 1 point, minus 4.5, and so on. It increases, decreases like this. So you should ask the student why this alternate way of graphing has been taking, and they should be able to reason this. So these are some of the simulations that I was able to look into for this particular concept, that is on usage of graphs. In fact, we have done so many graph and situation-based graphs in your SWOT equations. You can look into that also, but these are a little bit different over here. I found this one to be interesting whenever we are doing something on graphs. Okay, so with this, I think I've come to an end to this one. This is shorter one, shorter concepts, shorter tools. You can, if you get to know more about any of these graphs, if you have designed something like this, please do share with me. I would like to make a video on it and put it across so it is useful for everyone. Okay, thank you everyone. So before you leave, do share, like, and subscribe to my channel so to get whatever updates I'm doing, so you'll be able to get it across. Thank you once again.